Back in the early days of consumer photography, Kodak was king of the hill. With a large film and camera manufacturing plant in the northwest corner of Toronto, Ontario. The campus at one time comprised 16 buildings. All that's left is building number 9, shuttered since 2006. This former recreation and entertainment facility for Kodak employees is now the repository of 66 years of a company's and the community's memories. So when it became clear that Building 9 lay squarely in the path of Metrolink's expanding transit network, they devised a plan to preserve some of Toronto's not-so-distant past and convert Building Number 9 to a modern train station. But first, it would have to be moved out of the way to allow for construction of the necessary rail lines and transfer access. And that's where the engineering acumen of Western Mechanical comes into play. They have experience with moving very heavy, but extremely delicate behemoths. Western will employ the same series of hydraulic motors and rollers that were used on the Nipigon Bridge to guide this building along steel-plated concrete runners.
You have to think about the equipment that we have and the best, most economical way of doing it.
Weeks of preparation went into digging out the building's foundations to construct the runners underneath. Then, the exterior walls had to be severed at the base. Massive steel beams were slid into place atop the hydraulic rollers.
Okay, that's good there. It was a tough go. We had to get these 44-inch beams in there that were 160 feet long and then thread the 75s on top of them.
This 1.2 million pound crosshatch of steel is designed to support all 5 million pounds of this building. Once in place, the original support columns will be severed. Lifting the building from its moorings is the critical part of the operation. Any error in calculation would result in an uneven lift and destruction of the heritage structure.
The biggest task of that was trying to preload some of the beams, because as the building was elevated, we had to make sure that it all comes up at the same time. Some parts of the building are a little lighter than others, and the engineers did a great job, because as we saw cutted and lifted the building, it all came up as one unit.
The building's entire weight now rests upon the new steel.
So we got here is an electric powered hydraulic unit. They are usually used with our strand jacks for hoisting things, but now we're using them just to drive the rollers. So we got a 15 horsepower variable speed motor in there controlling a pump, which is then split off through the hoses. Each hydraulic pump runs 2 of the motors, and they're all linked together and communicate back to the laptop where we're operating from.
After months of prep work, the big day has finally arrived. There will be plenty of prying eyes on a job this unique, so Western doesn't want any hiccups along the way.
We don't have huge concerns, but we want to monitor our dollies to make sure that they're running straight. So I'd like to keep it slow. I think 20 feet would be a good indication to see if the dollies are rolling straight and to see if we have to do any corrective measures at that point.
They want us to monitor the track as it rolls down just to make sure everything is kind of staying where it should be. It's a very accurate instrument. It'll just give us the elevations where things are, and we can kind of tell everybody and kind of let everybody know, yeah, we're good, we're good.
This morning, Brian and I are just walking around having a look to see if everything is looked after and things look in fine shape. So this morning, hopefully things go well, and this afternoon the building should be sitting at the end of the runway.
The crew has an all-important safety briefing moments before the roll.
Everybody has the ability to tell the operator stop, right? Anybody who's inside the building at the time of rolling, any loud cracks or anything like that, that'd be the time to head out. So Maggie will tell us when things are going to start to roll. She's going to be here with the project manager for Crosslinks, and they're the ones who are going to say, okay, let's go. 4 minutes.
Very good.
All right, boys. See you at the end.
Okay, Maggie! Doug, we are a go.
And with those final words, the building begins its migration.
Okay, boys, we're rolling.
We get some grease on the track here on the lead too.
Early on, there are signs of a problem. One dolly has shifted 1/8 of an inch, and the massive load is denting some of the steel underneath. It is thought that the culprit is the slow speed, allowing the weight to sit on the runners. The solution? More speed.
Okay, Andrew, let's take her up a bit more.
Copy that. 50%.
Ollie, check your wheels. Are they still the same? Oh, yeah?
They're actually straightening out.
Things are rolling good. We're at about 50% of our expected speed. We'll probably travel like this until we know that the columns have cleared the one north of it. But we just want to make sure that we have everything clear before we actually ramp up the cheetah speed, as 10 Watt would call it. The black wall is clearing that column. Okay, Andrew, I think we're clear to give her another gear.
Copy that. Grabbing another gear.
The roller system is operating perfectly and on schedule, but the team remains on high alert.
Yeah, Doug, we're running 75% here. We got one more gear left.
Okay, give her the last gear.
Everything's working so well that we're able to go at full speed and everyone's happy and things are looking great.
With the system ramped up to full speed, the crew at Western gives this historic building one last gentle yet mighty push towards a seemingly impossible goal.
All I can say is the crew, the boys that have been working on it, have done a good job.
Through expertise and ingenuity, that impossible goal is now a reality.
And we're done here, brother. All right, fellas, that's it.